Now we are recording. Okay. Algebra of functions. If I ask you about arithmetic, how many operations, arithmetical operations, do you know? Do you know at least one? What can you do with two numbers? Add them, subtract them, divide, and multiply. So there are four basic arithmetical operations we could do on real numbers. Same thing with functions. There are four basic operations we can do on functions. We can add functions, we can subtract functions, we can multiply functions, we can divide functions. There's also a fifth operation that is unique to functions. It's called composition of functions. And we might not get to talk about that yet. But the idea for compositions, you'll see it in college algebra, is when you take one function and you put it inside the other function. So you replace a variable with a whole new function. But for now, we're just going to focus on addition, subtraction, what else? Multiplication, and division. So the idea is very straightforward. I mean, if you understand how to combine like terms, right, then you know how to add two functions. It's basically combining like terms. If you understand how to combine like terms, you can subtract two functions. If you understand how to FOIL, you can multiply two functions. You know, you just do your basic algebraic operations. Division gets a little sneaky. And the bigger problem with doing addition, subtraction, and so forth will be finding the domain of a new function that comes up after this operations. Okay? So that's going to be the bigger question. It's not just finding the new function, but also stating the domain of the new function. Now, your book gives a definition of what it means to add two functions and find the domain of that new function. And that definition is needs a little more precision, so I'm just going to give you a pretty precise definition of what's going on. So definition. Let f and g be functions, and let set A be domain of f, and let set B be domain of G. So A is the domain of F, B is the domain of G, two functions. Each one of them has their own little domain. Okay? That one? Domain of, F. Yeah. So A is the domain of F, B is the domain of G. Then we define the following, and here's a special notation. For the addition, we use this notation, F plus G of X. This is a new function that is defined as an addition of F and G, which literally means take F of X and G of X to it. So it's F of X plus G of X. That's just a new notation. But now let's think about the domain of this new function. So A makes F function well, right? A is the domain of F. So A makes F happy. B makes G happy. So everything inside of A makes F work. Everything inside of B makes G work. Well, what makes the sum of these two work? What makes F and G work at the same time? How do we find something like that? That makes both of these functions happy simultaneously. What am I kind of describing? What? No, range would be the range, but I'm still talking about the domain here. So A is for F, B is for G, and I want to make F and G happy. f and what? Addition? Well, I don't know how to add sets. What are you smiling about? You know the answer? The and, the big hint? I'm not going to just teach you. You're going to get it. Well, and when I'm making such an accent on the word and, what am I talking about? A and B. What does that mean? Multiply what? What? Well, is it union? Is and works with union? What? Think about sets. I'm using the word and. What am I talking about? A and B. What am I talking about? Are you just guessing? Flip through your notes or whatever. I'm talking about two sets, A and B. What am I trying to describe when I use the word and? Intersection. I'm talking about the intersection of the two sets. Because everything that both sets share will make this new function happy. A and B, right? Remember, and is intersection, or is the union. So the domain here is A intersection B. So in order to find the domain of the new function, I have to make both functions work at the same time. So I'm looking for the numbers that both sets share, and that's the intersection. So the same thing will work for the rest of the functions. If I want to define the difference of two functions, so that's simply f of x minus g of x. But domain would be the intersection. A intersected with B. Because both of these functions have to work at the same time. Same thing with the product. We define a product of two functions as, well, a product of two functions. F of x times g of x. That's a times there. And the domain will still be the intersection. Because again, both functions have to work at the same time. Okay, well, let me give you an example right away. Let's say A is from -2 to infinity, hypothetically speaking. Don't write this down. So means F works on this set. Now B is from -infinity to 5, right? So, I'm sorry, B is from -infinity to 5, so G only functions on that, right? Well, now I'm looking at the function F plus G, for example. So I want to make F happy and G happy at the same time, So A has numbers in it that will make G very upset. Agree with that? Like, if I let x equals 10, G is not good with that, right? At the same time, if I let x equals -5, the function f will not be good. So I need to find the set that makes both of these happy. So I'm really looking at the overlap of these two things, which is the intersection. So what will be the intersection here? What is the overlap between these two sets? Where do these two sets overlap? Well, what numbers do they share? No, this one starts at -2, so it doesn't. From -2 to 5, right? These are the only numbers that these two sets share. I mean, if you graph them, if you have problems finding intersections, graph both sets. Here is set A, from -2 all the way to the right. Right? This is A, including -2. You know that? Now B is from -infinity all the way to 5. Now where do they overlap? So it's from -2 to 5. All right? This is the region that makes both functions function properly. Yes? Well, union then, if I take the union, that's everything then. There will be all real numbers. Remember, union, you just pile everything together, including the overlap. So the union of these two sets is all real numbers. So that will make some of those functions not function properly. Is that okay? Okay. Now for the division, the way we define division of two functions, So it's just f over g of x, which is f of x over g of x. So still, I have to make f work, I have to make g work. So still the domain would be the intersection of both sets, but, oops, there's one more issue I need to take care of. Since I put g in the denominator, I have to also make sure that g is not 0. Right, so I'll write something like that. Also make sure that g of x is not 0. Because there might be some numbers that make g equal 0, which is fine. Right? G still works, gives you the answer of 0. But when you put it in the denominator, it gets a little weird, so we have to take care of that. So let's try this example. So let's say f of x equals 2x minus 1, and g of x equals x squared minus 4. Okay? So this is a nice example because what is the domain of f when it's just 2x minus 1? What? Nothing? Nothing? Oh, A, okay. Well, what was that? All real numbers. Domain of f is all real numbers, right? Because again, you only worry about the division. And since function f by itself does not have any division, domain of f is all real numbers. What about g? What's the domain of g? What? All real numbers. So you can say, A equals all real numbers, B equals all real numbers. So if you take the intersection of A and B, what do you get? All real numbers, right? So there's no exclusions. So really, the domain for some difference product will just be all real numbers, right? Because there's nothing bad happens here. So for example, if I ask you what is f plus g of x, well, you'll say all you have to do is to take function f, and I wrote f wrong, it's 2x minus 1, and add function g to it, right? This is f, this is g, f plus g. Can I simplify this? Can I combine any terms in there? Yeah, so it will be x squared plus 2x minus 5, right? So that's that new function. Domain of that function will be real numbers, set of all real numbers. Is that okay? For now, yeah. We don't have any other operations. Very soon we're going to add square roots to our area of concern. For now, it's just variables in the denominator. That's literally all we worry about. You can have a fraction, but let's say if I make it, let me use my magic pen. I have a magic pen? Look at that. If I add a denominator, if I make it like over 13, well, that doesn't change anything. 13 can never be 0, so domain is still all real numbers. As long as there are no variables in the denominator, we're good to go. It's a magic pen. Disappeared. All right. Now, with the difference, you have to be a little bit careful. So it's f minus g of x. So that means I have to subtract the entire function g, right? So the way you express that, if you want to subtract the entire function, you have to put that function in the parentheses to make sure you're actually subtracting the whole thing, so the negative gets distributed and the all signs change in the process. So then you get 2x minus 1 minus x squared plus 4, whatever that equals to. 2x minus x squared plus 3. You can write it like that. Yes? I can if I want to, but the addition does not change any signs, right? So if I put, actually it would be a good practice to just put parentheses over everything, just to make sure you don't miss any signs. But then when you distribute, when you're trying to drop the first parenthesis, you just drop it because there's nothing in front of it, right? There's 1. Same thing with the second parenthesis, just plus whatever, so there's a silent 1 there if you distribute that. Nothing changes. While here, the only thing that matters is that negative. Does that make sense? So yeah, you can put parentheses, it's just to be safe. And that would be a good practice, actually. Any other questions? What is the domain of that new function? All real numbers. And that's just basically, it's irrelevant to what function looks like. We knew beforehand that the domain is going to be all real numbers because we found that intersection at the very beginning. Is that okay? How about product? Fg of x. So that tells me to multiply both functions. And this is where we're going to have to FOIL, right? We're going to have to FOIL to open up the parentheses. So it's 2x times x squared is 2x cubed. 2x times negative 4 is negative 8x. Negative 1 times x squared is minus x squared. And negative 1 times 4 is plus 4. And you can leave it like that. You don't have to order them in a descending order or whatever. And you can if you want to. You don't have to. And again, what is the domain here? All real numbers. How about this one? Let's do f over g of x. So that means f is in the numerator, g is in the denominator. Okay? Now what is the domain of this new function? Is that it? Nick, yes. Well, what cannot equal to 0? X or? All right, well, so then tell me exactly what x has to be so g of x does not equal 0. Well, if I can plug 0 in there for x, right? Is that it? 2? Is there any other numbers? Is that it? That's what I agree with 2. All I'm asking you is that, are there any other numbers that might turn the denominator into 0? Negative 2. So those are the 2 things you have to avoid. Did you say that? You have to be more, no, I don't hear you. Oh, I thought you did. Oh, you see it now. So this is what I told you guys earlier. It's always a good idea to factor when possible. I don't know if you see how I factor that? But anyways, yeah, 2 and negative 2. So these are the 2 numbers you have to avoid. These are the numbers that make g of x equal 0. So these are the numbers that turn the denominator into 0. So the domain here would be all x's, so x does not equal plus minus 2. Well, it's here. It's negative 2 times 2 is negative 4. We'll talk about these fancy factoring tricks a little later. Well, the answer is that. You don't have to factor, but it will help you to see that there are 2 numbers, 2 and negative 2. It's easy to see 2, and it's easy to forget negative 2. But if you factor that, then you see the first parenthesis, x equals 2 makes that 0. While the second parenthesis, x equals negative 2 makes that 0. Right? Is that okay? No? Or you can just think about it and say, well, there are 2 answers. What if I go the other way? What if I go g over f of x? So I'm putting g in the numerator, and I'm putting f in the denominator. What is the domain of that? Hmm? Well, again, just ask yourself a question. What turns the denominator into 0? I mean, you can literally solve it. I mean, what makes this equal 0? How do you solve that? 1? Well, 2 times 1 is 2. 1/2, right? If I solve this, actually, go through the motions, I get x equals 1/2, right? So these are the numbers I have to avoid. So it's all real numbers, so that x is not equal to 1/2. And yeah, you don't have to guess. You can just take it aside and just solve for 0. That's linear equation that you like, and they'll give you an answer. Any questions on this? Let's see if I have more examples. Okay, well, let's make one up. So another example, f of x equals 1 over x minus 2, and g of x equals x over x plus 1. So first, before we start doing anything else with these functions, let's find the domain of f, let's find the domain of g, and let's find the intersection, because that will answer all the domain questions, mostly. So, what is domain of f here? Anyone? So everything but 2. Right, okay. So the domain of f is all real numbers except for 2. Yes. What about domain of g? Right, so all real numbers except for -1. So then the future domains of additions and subtractions will have to do the intersection of a and b. So that means we cannot have 2, we cannot have -1. We have to exclude those 2 numbers. So the intersection will be all real numbers except for 2 or -1. Well, I shouldn't use or. Let's just separate them with a comma. That's fine. So x cannot equal 2, x cannot equal -1. That's the intersection. So then this will be the answer for all the domains, for the addition, for the subtraction, for the product, and so forth. So if I ask you find f plus g of x, then it's just 1 over x minus 2 plus x over x plus 1. Right? The addition of 2 functions. Now, there is a way to actually add these 2 fractions. We're not going to do that yet. We're going to learn a little later. But if you have to add 2 fractions, what do you need to do first? If you think about this. Yeah, get the common denominator. So we'll have to be able to learn how to do the least common denominator for these types of rational expressions, see how to convert them so they have least common denominator that is shared, and actually add the function. But we'll do that later this semester. So for now, that's the answer. Yeah. Now, if I ask you the difference, So that will be the difference of the two functions. Again, we don't possess the skill of finding the LCD for that types of algebraic expressions, so we're just going to leave it like that. But what is the domain of these two functions? Yeah, so it's right there. We already found it, right? That was the whole purpose there. So the domain for all of them is all x's, so x is not equal 2, x is not equal -1. If I ask you to find the product, it'll be the same idea. Fg of x is 1 over x minus 2 times x over x plus 1. Right? This one can actually, it's easier than adding, because when you multiply fractions, you just multiply fractions. Right? You multiply the numerators, you multiply denominators. So really this whole thing is x over x minus 2, x plus 1. You can write it like that. Right? You just multiply the numerators, multiply the denominators. What is the domain? Yeah, it doesn't change. You don't even need to see this. I know you can still kind of see that, but it's just whatever this thing we found earlier, that will be the domain, regardless of what this mess looks like. Okay, so I'm always tricking you with the domain question. We already found it. It's always the intersection. Finally, let's do f over g of x. So that is 1 over x minus 2 divided by x over x plus 1. Is that okay? How do we divide fractions? Yeah, multiply by the reciprocals, right? You have to flip the second one, so that becomes 1 over x minus 2 times x plus 1 over x. Right? Division is multiplication by the reciprocal, and then you can multiply across. So let's just leave our answer like this for now. What the hell? So the big question now is, what is the domain of that new function? So let's go back to this point, right? This is what we agreed on. The domain of a fraction, domain of the division, is still going to be the intersection that we found earlier, plus make sure the denominator is not 0 of the original g, right? You don't want g to equal 0. So it's whatever we found before, the intersection, and then take care of the fact that g should not be 0. Okay? So let's go back. So let's see, g shouldn't be 0. Here's g. Can you tell me, when does g equal 0, the whole function? What does x have to be in order for the whole function to be 0? Well, -1 will make the denominator 0, right? If you plug in -1, you'll get -1 over 0. That's undefined, so that's a different story. But the entire thing, so what does x have to be for the whole function to equal 0? When does a fraction equal 0? What? But if the denominator is 0, just think about the fractions. If a fraction, let's say a over b, right? And I want that to equal 0. The numerator has to be 0, right? 0 in the denominator, that's undefined. That's this part, right? That's what makes us undefined. But what does it make it 0? When the numerator equals 0. So what makes that numerator equal 0? 0. So that means we need to remove 0 from the domain as well. So the way you can find the domain of this new function, Again, I don't need to see whatever this is. I can just go, it's still the intersection, and then whatever makes the whole function 0. So I need to exclude 0 from the domain, right? Because x is in the numerator, whatever makes 0 is 0. So the domain here, x cannot equal 2, x cannot equal -1. That's what we started with. And x cannot equal 0. The weird thing about this answer is that if you look at this function as it's written, you recognize that x shouldn't equal 2, right? You recognize that x shouldn't equal 0, because there is x in the denominator. But this doesn't tell you that there is also an issue with -1. But the issue from -1 was the way g is written originally. -1 does not play well with the g, so this is why we need to keep track of the original intersection. So see what we did? We found that intersection at the very first step, and we just kept copying it over for all 4 questions. Except from the very last part, we just look what makes g equal 0, and in this case, x equals 0 makes g equal 0. So we had to add that part. Isn't that fun? Yay. All right, well, what if I flip it? What if I do g over f of x? So that's, x over x plus 1 divided by 1 over x minus 2, right? G divided by f, so flip f, so that becomes x over x plus 1 times x minus 2 over 1, and then you just multiply them straight across. Whatever that is, yeah. 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 You're going to reflect back on this period as good old days. So what's the domain here? X cannot equal 2. X cannot equal -1, because that's what we started with, right? That's our starting point. X cannot equal 2, x cannot equal -1. That's always going to be the case. Now, does anything going to make f equal 0? Because that's the question now, because f is in the denominator. F should not equal 0. So let's look at f. Can f equal 0? Now, why do you say no? Right, because the numerator is 1. 1 is not 0. No matter what x is, the numerator is going to be 1, right? 1 divided by anything is not 0. So nothing turns f into 0, so we're done. Okay, and again, if you look at this function, we see that -1 is a problem. 2 was a problem, part of the original intersection. But then there's nothing new in the denominator. Like before, we had that extra x. You can always reason that extra x produced the fact that x cannot equal 0. But here is just, nothing else added to the denominator. But again, your best bet is to think, going back to the original expressions, going back to the intersection, and just separately thinking what makes the denominator function equal 0, and just dropping that extra piece of information in. Okay? It's always, you don't want to be thinking about the domain over and over again. Just do it once, so you don't have to worry about it for addition, subtraction, or multiplication. It's always going to stay the same. Only for division, make sure that your denominator is not 0. Whatever your denominator function is, going back all the way to the original expressions. Is that okay? Who's with me on this? You look a little dazed and confused. So what? It's a Monday. How about this one? F of x, let's make it x over x minus 3, and g of x is 4x plus 3. What is the domain of f? Just the way f is written. What? You should not say 3. You should say everything but 3. Because if you say 3, then f only has one point in the domain, which is 3. Well, the domain of f is the exact opposite of that. I mean, you're thinking correctly. You just have to persuade me that you understand it correctly. Okay? What is the domain of G? All reals. There's no division, so domain of G is all real numbers. So we should do that first. It will help you to see what the domain of all future function is going to be. So if you take the intersection, what will be the intersection of these two sets? First set tells you avoid 3. The other set tells you everything goes. So which numbers do we need to avoid then? Just 3, because that's the set B does not contribute anything new to our domain. So that's the domain of the intersection. I mean, this is the intersection, so this would be the domain of addition, subtraction, multiplication without even thinking about what the new function looks like. So if I ask you, just find the domain of, whatever f minus g of x can possibly be, if that's the question, without asking you to find the actual function, the answer is this set. Domain would be just all x's, but 3. I don't need to see what this function is to answer the domain question. Domain is always going to be the intersection. Is that okay? So that will be the answer for addition, subtraction, multiplication in any order. If I ask you for the domain of, whatever, g minus f, what would domain of g minus f be? Everything but 3. That does not affect the domain. Which order I subtract them does not add anything new information to the denominator. I still have to make both functions happy at the same time. So I just have to avoid 3. Okay? The only time it gets a little fuzzy is when I start dividing. So if I ask you, just find the domain without even looking at the function. Find the domain of f over g of x. So the way we know to find the domain of the division is it's still going to be that intersection plus, what is my denominator function right now? Which function is in the denominator? G. So I just have to make sure g does not equal to 0. Right? Look at g, 4x plus 3. When does g equal to 0? Negative 3/4, right? So that's the extra number I need to avoid, right? If I take 4x plus 3 and I set it equal to 0, so negative 3/4, that's what makes j equal 0. Since I'm putting g in the denominator, I need to avoid negative 3/4. So the domain here is all real numbers except for 3, except for negative 3/4. I don't even need to see what the new function is. I can still find the domain. The intersection plus whatever makes the denominator function equals 0. Is that okay? What if I flip this? Find the domain of g over f of x. Again, I don't need to see this new function. I know x cannot equal to 3. That's just set in gold. It's not going to move. Okay? Now, since I'm putting f in the denominator, I need to do everything possible to make f non-zero, the way f was written originally. What makes that f equal 0? What makes numerator equal 0? 0. So avoid 0. And that's it. Okay with me? So I don't even need to compute these new functions if I'm not asked. If the only question is find the domain, I can go from the what's written originally. Questions? Does that make sense? A little bit? Good. So, well, not really, just one concept. Just keep this in mind. So you see what we did first? Find the domain of each function individually, right? That's the first thing that you need to do. And the second step is find the intersection. So this is your ability to play with sets. If you're confused on finding the intersection, just draw them out as I did before. Just make the graphs and see where they overlap. Because if I try to do that with these two sets, everything but 3 what? Here we go. So if this is 3, so I need everything but 3, and then I need everything. Right? This is the top would be all x's except for 3, while the bottom is all real numbers. So where do they overlap? I mean, they overlap almost everywhere except for this part. That's what they don't overlap. So this is why the intersection is just everything but 3. Is that okay? All right. I can ask you this question. Let's say I have this function, -3, 1, that's 2, let's say 3, 0. So I have this function. Let's call this f. And then I have this function. So let's call this g. Okay? I have 2 graphs. Although both functions, everything's nice, right? Blue is f, red is g. Now I can ask you this question. Can you tell me what is f plus g of 0? Just by looking at this graph, can you evaluate the sum function when x equals 0? Right? Because I mean, what I'm asking you to do is literally to take f of 0 plus g of 0. Right? That's the definition. F plus g of x is f of x plus g of x. Can you tell me what f of 0 is just by looking at the graphs? 1. So f of 0 equals 1. Somebody said 4. That's the full answer. What is g of 0? 3. So then the answer is 4. So f plus g of 0 is 4. You're just adding the 2 values. You can do it graphically. It's literally taking height of one function and putting above the other function. So the f plus g actually ends up over there. See what I did? I took this little chunk, just place it on top. So I can do this along the entire graph. I can visually come up with a sum function. What about f plus g of -3? What would that equal to? Well, why not? 0, because what is f of -3? And what is g of -3? And 0 plus 0? 0. So yeah, because this is really what we're doing. We're splitting them in 2. So that's 0 plus 0. So that's 0. So I'm just taking the 2 values separately and doing the whatever operation you're asked to do. Is that okay? All right. How about f times g of 2. Four, because you have to take f of 2 times g of 2. Well, f of 2 is somewhere here. F of 2 equals 2. And g of 2 equals 2. You agree with that? Just by looking at the graph. So it's 2 times 2, so the answer is 4. How about f over g of 3? So again, remember, what I'm asking you to do is to find f of 3 and divide it by g of 3. So what is f of 3? 0. And what is g of 3? 3. So 0 over 3 is 0. But if I ask you what is g of f of 3, so it's g of 3 over f of 3. So that's 3 over 0. And that's undefined. So we can answer those types of problems just by looking at the graphs. How's that? What? Oh, okay. So let me ask you this, then. Try it on your own. So I'll give you f of x equals x squared. Let's not do squares. So f of x equals 4x plus 1, and g of x equals negative 2x plus 3. So I want you to find and state the domain of, so I want to do all 4. F plus g of x, so find the function, state the domain. F minus g of x, find the function, state the domain. F times g of x, find the function, state the domain. F over g of x, find the function, state the domain. Now let's do g over f as well. So I want you to find the actual function in each case. Yeah, and tell me what domain is. Okay. What's the first thing that you need to do? What? Yeah. Find the domains of each, find the intersection, and then kind of stick with that. So see whether you can do this problem. Let me pause this. Well, no, I want you to find the functions as well. So you have to tell me what each function is. But the domain, again, it's irrelevant to what the function looks like. It's based on what we had stated originally. So can you tell me what is f plus g is? What is this function, f plus g? When you just 2x plus 4, you just add 4x plus 1 and negative 2x plus 3. You add them together, it's 2x plus 4. Domain, again, is, clearly it's all real numbers, but again, it doesn't matter what it looks like. What did you get for the difference? What? No. 6x minus 2. Make sure you put the parentheses around the function that you are subtracting, so the negative gets distributed. So you subtract the whole function, not just part of it. Because if you don't distribute the negative, you're really subtracting whatever the first term is, but then you're adding the rest of them. So yeah, that will be 6x minus 2, but the domain is still all real numbers. Now for the product, 4x plus 1, negative 2x plus 3, what? What did I forget? Oh, okay, you're giving me the answer. I'm sorry. I thought that. But anyway, so let's, whatever you just said, negative 8x squared plus 12x minus 2x plus 3, right? Combine like terms. So negative 8x squared plus 10x plus 3. But the domain is still all real numbers, regardless of what that function looks like. Yeah, it's a plus 10x plus 3. Oh, it's still all real numbers. I mean, that we already discussed that. That's just always going to be, for the addition, subtraction, multiplication, it's whatever you find first is that intersection. In this case, it's all real numbers. But then if I go for f over g of x, I mean, it's just some function. I'm sorry, what was your question? Well, here it is. It's that function with that domain. Yeah, so fg of x is that. Just some new function. We can classify it as a, I think you said quadratic function. We don't need to worry about how to classify it. It's just a function. Domain all real numbers. But with the division, f over g, so g is in the denominator, right? So you need to avoid 0. G cannot equal 0, right? So if I do a really quick equation, if I say 2x plus 3 equals 0, and I solve that, what does x equals to? What? Yeah, 3 halves. So negatives cancel, so 3 halves. So x cannot equal 3 halves, because that's what makes g equal 0, and we're putting g in the denominator. The fraction itself is going to be 4x plus 1 over negative 2x plus 3, and the domain here, all real numbers except for 3 halves. X cannot equal 3 halves. And then you can actually see that just by looking at the function. Just everything else works except for whatever makes the denominator equal 0, right? If we do the opposite, g over f, so that's negative 2x plus 3 over 4x plus 1. Yeah. Three halves, yeah. So whatever we found here, the 3 over 2. So how about this one? What x cannot equal to? What? Negative 1/4. So you do the same thing. You set the denominator function equal to 0. You solve for x. You get negative 1/4. That is the number that needs to be avoided. How's that? Yes. Well, usually, again, you just take this function and you set it equal to 0. Because again, remember this fact. Because we're just going, no, not this fact, but this fact right here. We're using this concept. Because what does this thing say? First, find the intersection, which we did. That was the all real numbers for our cases. And then it says, whatever the denominator is, make sure it's not equal to 0. Right? That's what this notation represents. G of x is in the denominator. G of x cannot equal 0. Right? So this is what I need to add to the domain. So when I go back to the problem we were just working on, I'm looking at this. G is in the denominator. So I'm looking, okay, well, what is g? Here's g, 2x plus 3. When does that equal 0? So I'm just, that's a simple linear equation. You set whatever the g of x is equal to 0, you solve, you get 3/2. So that's the number that we have to exclude, because that's what makes the denominator equal 0. Now, same thing with the second one. The denominator function is f, right? So what is f? F is 4x plus 1. If I take f and set it equal to 0, and I solve that, I have to subtract 1, divide by 4, so negative 1/4. So that's what I need to avoid. Yeah, top doesn't matter. Because again, we have to go all the way back to whatever this says. That's only referring to denominators, right? The top can contribute if top itself is weird, if A is something else. But this is the intersections taking care of that. Because again, the answers to addition, subtraction, multiplication, as far as the domain is concerned, is always going to be the same. It's always going to be the same domain for addition, subtraction, multiplication. Division, you just have to add this extra area of concern that we have to be careful with. Does that make sense? And this is what we're doing. This is what we're doing here. We're still starting with the intersection. It's all real numbers. I mean, if you think about this set is all real numbers but one. Just one number is excluded, and that's the one that was making the denominator function equal 0. Yeah? Any other questions? Sure. So this makes sense? It's a little weird. It's kind of, I mean, before I can just ask you, and this is what I'm still going to do that. I'll just give you this function as it's written and ask you, what is the domain of this function? You're still going to give me the same answer. Everything but negative 1/4. That's what makes denominator equal 0, right? The only time when this thing kicks in is when I look at this example, the one we did with 2 fractional functions. Because when I start excluding 3 numbers, you do not see it from the final result. The final function here suggests that x cannot equal 2, but x cannot equal 0. But it doesn't say anything about negative 1. We don't see negative 1 as a problem here. But negative 1 is a problem for the original function. And that's why it was kind of excluded. So this is the intersection part. That's what kicks in. So if you were just given this function without any of that division stuff, just here's a function, find the domain, well, it's everything but 0 and 2. But if you're giving this function in this context, that it's actually division of other 2 completely what's the word? Sustainable functions or whatever, then you have to make both functions happy and the division happy. So that's what adds an extra piece. But you don't need to think about this if you just stick to the intersection. Find the intersection first, and then go from there. Yeah? What do you mean, uh-huh? I have no idea what I'm talking about. Okay. So, anyways, that's the problem. All right, so that section 2.6, which is this thing right here, right? And we were supposed to do that on Wednesday, so we're a day ahead of the schedule, right? As of right now. Because, I mean, on the 10th, yeah, so we're 1 day ahead. If we keep being 1 day ahead, because right now our first exam is scheduled October 8th, exactly a month from now, with the one review date before. If we stay 1 day ahead, that just gives us an extra day of review. I'm not moving the exam date. It'll just be Whatever days we save, that's more review days. Does that make sense? So, all right. Well, I'm not going to start chapter 3 now. So go catch up on your homework, because I've changed the time. But there are a few other assignments, right? There are many assignments that are coming due soon. And there's a quiz in there, too. Right? Did you see all that?